Thanks for coming. This is Architecting High-Performance SQL Server on Virtual Machines. I'm Anthony Nocentino. I'm a Principal Field Solution Architect at Pure Storage, where I specialize in system architecture and performance. I like to build systems. I like to make things go fast. I am a Pluralsight author. I have a whole bunch of content on SQL Server, Kubernetes, containers, and things like that. I'm glad you're here because my friend Andrew Prusky is presenting right now in another room, and whoever has more people in their session has to get some free beer tonight. So I appreciate y'all coming. I like Guinness, Andrew likes Heineken. We're on Team Guinness, okay? All right, so hopefully tonight we'll add it up. We'll put it on Twitter and let you know who won. Awesome. Fantastic presenter, by the way. World-class, long-term friend. So I'm glad that you're here with me because certainly that's a hard choice to make. So we're going to talk a lot about SQL Server on VMware. Who runs SQL Server on VMware right now in their environment? Okay, nearly everyone. Not to say who doesn't, but who doesn't run SQL Server on VMware, specifically VMware. Okay, cloud, probably, Hyper-V, okay. So yeah, we're going to talk a little bit about that. We're going to talk a lot about hardware, but not that much, right? Because in the end, it's about how we're going to consume the hardware to provide the services to the database engine to do the things that we want to do as database professionals. And so we're going to talk a lot about virtual machine configuration and what that looks like. We're going to look a little bit about SQL Server configuration, and I'm going to tell lots of stories. I was a consultant for a very, very long time. I now work at Pure. I get to see lots of customers in the field and their configurations, and there's a reason why I wrote this setting, because a lot of this information isn't getting out to the community. I see a lot of things that could be done better, right, to drive high performance out of your systems. Generally, I love doing super deep dive talks, but this isn't. This is more of a higher level talk about how to build the platform so that you can templatize that and build a better system for your data services. So I'm going to assume today that you know what a virtual machine is. About 99% of y'all raised your hands when I asked who's running a SQL Server on VMware, so that's probably a safe assumption. I'm also going to assume that you're not in charge of your VMware environment. So who's actually in charge of their VMware environment? All right, so single-digit hands. I think 2 or 3 hands just went up there. I'm going to assume that you're most likely a DBA, right? DBA's in the house? Yeah? Yeah, all right, that's safe assumption too. Good. And I'm going to focus, sadly, because if y'all know me, I love a certain type of deployment method that generally isn't virtual machines and generally isn't Windows, but here we are, right? Because who runs SQL Server on Linux? Containers, probably, right? Yeah. And I have no demos. I'm just going to tell lots of stories throughout. So just kind of exchange some things that I've seen in my career, right? And I talk a lot about containers. I probably spent the last 4 years of my life talking about containers and Kubernetes. But as y'all just showed me, about 90% of people run SQL Server on VMware, specifically VMware, right? Well, maybe a couple Hyper-V, we see that a little bit. And then obviously cloud is going to eat away at that number a little bit. But in the customers that I've seen in consulting, and I see today in where I work now, that's a pretty big number, right, for a deployment method. And so that's why I wanted to talk about what I wanted to talk about today. But I do see some SQL Server and Linux out there, primarily in containers for non-prod environments, right? Who uses SQL Server on containers? Anybody? No? Yeah? Not in production, just like for fun, like to do dev, test, right? And I think that's the niche, right? Because everybody loves being able to do Docker run whatever, and you get a SQL Server in as fast as your internet connection can deliver you a container image. That's pretty awesome. If you haven't worked with a SQL Server on containers, I highly suggest you doing so for development and getting things up and running and things like that. So we're going to talk about what a VMware environment looks like, right? And what that really means is you have something called a cluster. And this could be in Hyper-V too, kind of the same concepts apply. And you have a collection of physical servers that contribute some amount of CPU and memory to the cluster that you can consume, right? And then you come along later and you create virtual machines that will have some sort of configuration with regards to how much memory and how much CPU they'll use. And that's going to be allocated from the underlying system. We're going to talk a lot about scheduling and memory configurations and things like that. But this is what virtualization brings to the party. You have this abstracted away physical layer that gives you a consistent layer to deploy VMs on, right? In specifically VMware. We'll talk about some automation and things like that towards the end. And so when I talk to customers, especially in the consulting days, the first thing that I would ask for is to have a dedicated cluster for SQL Server. Like those physical machines that were part of that cluster, I would always ask, can I please have, if your budget permits, a dedicated cluster. And it has to do with how scheduling works inside of VMware with regards to having something like SQL Server, which is going to sit on a CPU and do a lot of work, versus an interactive workload like an application server or a Citrix environment, things like that, web servers and so on. And also it has a simpler configuration. But generally, budgets are usually the constraint here, right, with regards to how we're going to use that underlying hardware. So if you can't, maybe ask politely again, if you can have a dedicated cluster, but you can dedicate hosts. So you can take that physical layer and say, you know what, just run my SQL servers on hosts 1, 2, and 3, but not on 4, 5, and 6, right? But you have to take into account that you have enough capacity to support your entire workload, right? Because you don't want a host to disappear and not have enough memory or compute to run your workload in a consistent way. And this is a very critical thing, whether you have a dedicated cluster or not. When I would build VMware environments, I would ask nicely, can I have n plus 2 hosts? Because I want to be able to lose a physical host and not impact the workload and have a negative impact on how fast that workload will be. Because I'm shooting for consistency in my applications, right? I don't want things to be periodically slow because a host is offline or something's being maintained or there's a failure. And back to the dedicated cluster idea is I want to have consistency in my workload. I want a query to run the same way all the time if it's mission critical, tier 1, right? That's what we're shooting for. Now, the way that you do this, and the VMware admins in the house probably already know what this is, you have this concept of affinity or anti-affinity rules to separate workloads. I can say this workload can run on these 3 hosts, and I don't expect y'all to configure this, but this is the conversation that you can go back to your VMware admins and say, hey, listen, I heard about these things called affinity rules. I can put my SQL servers on a subset of hosts so that I can get consistent performance out of those hosts. But if one of those hosts dies, I want to make sure that that guest can start somewhere else in the cluster, right? That's really what you want to shoot for when you're doing this. And there's a bunch of nuances and configurations around that we could probably spend all day talking about, but that's kind of the big idea there, is being able to run those on a subset of hosts within a cluster, or go back for a third time and ask nicely for a dedicated cluster, because it's a good idea. Now, if you're running availability groups or FCIs, just a bonus tip, a little bit to get into. So lots of folks run AGs and FCIs to support for high availability configurations for their SQL servers. Who runs availability groups? Everybody? About half y'all. Who runs FCIs, failover clusters? Okay, about half y'all. And so when you're doing that in a VMware environment, how do you guarantee that 2 replicas of an availability group aren't on the same host, right? That's where these rules can be applied to make sure that AG replica 1 and AG replica 2 are on separate hosts. And that way, if a physical host dies, what happens? Hopefully nothing, right? But if they're on the same host, physical host dies, what happens? Well, they'll have to start somewhere else in the cluster and you have an outage, right? Cool. And also, please, questions throughout. If you want error commentary, things like that, just to kind of get into. Cool. All right, calming down a little bit from the hardware failure. Yes? The question is it more important to separate SQL servers from production and test? Is that the question?
Yeah. Would you, if you have the affinity to keep tests not impacting production, or would you put all the database tests in the same kind of
That's a tough one because of budgets, right? I would ask for a separate physical environment because I want to be able to test the whole stack, right? If I have a driver update, how do I guarantee that that's not going to impact the other parts of the platform or SQL Server? As you go up the stack, I think it will become less critical, but it comes down to, can you get the budget to support that non-production environment? It's a tough one because it depends on the environment and the budget associated with that. But I would start there, and then obviously if they say no, you can't have that because of budget constraints, it kind of unwind it a little bit. When I build systems, especially in the consulting world, I didn't have unlimited budgets, and so I would focus more on making sure that I had test systems for SQL Server, I had test systems for availability groups and things like that. Those more advanced configurations, and I went down the stack, I lost less control in the environment, and I couldn't assert that, so, but good question. So you want to go fast, right? That's what SQL Server is kind of the nuance or the point of today's talk. And who remembers, probably if you're of a certain age, there was a button on your computer, it was called the turbo button. Do you remember that? My first computer had it, it was 8 megahertz and it was 12 megahertz. I hit the button, I was like, yeah, it's fast. What's that?
Did anyone ever run a computer with
Right, why would you run that? Well, nowadays you actually have that choice, and it's the default configuration. When you have a power plan on an operating system, let's see, click, click, in the BIOS or in ESX, you have the choice of choosing an energy efficient or balanced power plan. In fact, it's the default configuration out of Windows. And you've probably heard that this might provide some level of performance, but it provides a significant impact on the throughput, specifically in I/O, of a SQL Server. Because what the power plan will do is it'll modulate the clock frequency, aka slow it down, right? It's like pressing the turbo button and turning it off, right? So it literally makes the clock rate in the CPU go down, which means you can move less stuff, right? So when you're specifically in I/O, your I/O still has to go through the processor because as it gets pulled off of disk. And so if you're running a data warehouse workload, this becomes very evident very quickly, right? That the influence of just this one setting, well, in 3 different places, can have on your system. And obviously, this is on Windows or Linux too. So definitely look at your hardware vendors, look at your ESX configuration, and the operating system itself. Lots of folks are using things like UCS platforms, or they're using physical servers. Just talk to your server team and say, this is the end result I want. There's some buttons you're gonna have to mash in the documentation for UCS or HP or Dell or whatever, but this is the end result, is I don't want you influencing the power plan or the energy savings, unfortunately, of the system. And there's obviously an opposing force in energy costs and things like that, but that's a whole other session. So I worked with a customer last year, and we did this. We had to figure out how fast. We were iSCSI attaching storage to a physical server over multiple network links to a storage array, and it was a 30% decrease in I/O throughput just by changing that setting. And so if you're paying $7,000 a core times many cores, right? You go back to your CIO and tell them, well, they're not going to be happy if things are 30% slower. And so that could be significant. Yes?
With today's processes, should you be using hyper-threading, seeing as you're paying for a full core but not really getting a full physical core?
So has there ever been the question is, should we use hyper-threading, right? Has there ever been like a community definitive answer on the influence of hyper-threading on SQL Server workloads, or is it always it depends? It's always it depends, right? But what hyper-threading brings to the party is what's called an additional execution context, right? So I can have the instruction that's going to execute, and it's going to get onto the CPU, and that's going to happen behind it is it's going to pipeline the next instruction to go on to that second virtual core, which means there's less distance to travel for the thing to execute, to finish whatever the process is trying to do. Sounds better, right? So, because that instruction is going to be on core and ready to execute without having to go get the things off the registers or bring it onto the core. And that's going to provide some sort of performance input. The thing that I think I have seen some stuff around hyper-threading, this is just my guess, like it's from like 10 years ago, to not use it on data warehouse workloads, but I have no idea why. So if you want to look it up, that's where I would start. But I have always turned it on as a best practice in all the configurations I've worked with. Anybody else seen that best practice hyper-threading? Yeah? Yeah. No? Who said no? No? Oh.
There's been many discussions.
Right.
So,
Right. It's like,
I try not to set it on because I expect when the worker to see my engine to have the engine.
okay.
Context switched off.
Understood. So let's talk about CPUs and how they're allocated from an individual server. So we're zooming in on a physical server. Obviously, as we indicated earlier, a VMware cluster has a collection of physical servers. But we're going to talk about what happens on a single server in that cluster right now when I put workload on it. Okay? So let's say I come along and I start up a bunch of virtual machines in my system. So I think this is approximately 32 cores. That seems good, right? 32 and 32 matches. But we're going to talk about why. And we're going to talk about what happens when I do this, when I allocate that 36th core, right? And is this good or is this bad?
Depends.
Right, it totally depends. Because what we really care about is, are any of these VMs waiting to get their vCPUs access to the PCPUs, or the physical cores, right? Because all a VM is software that's executing inside of an operating system, or more specifically a hypervisor, and that hypervisor is going to get allocations to the physical resources. And so if that VM has to wait for any period of time to get access to those physical cores, what's going to happen to your application or your SQL Server, right? It's going to wait. And so this may or may not be bad. When I would work with customers that said they had tier 1 workloads, I would stop here, 32 cores. Why? Because no one's ever going to have to wait to get access to a CPU. But because of virtualization, what do I really want out of the party? I want to multiplex this hardware so I can get some sort of cost efficiencies on having less hardware, right? And so when you're looking at non-tier 1 systems, that's where you start to overload it a little bit or oversubscribe pCPUs or vCPUs, because now I'm going to gain some efficiencies or economies of being able to use that physical hardware more efficiently in my platform. But if it's a tier 1 workload and I sell things and I'm waiting for a transaction log IO, the last thing I want to have is have someone mash a button in my shopping cart to buy a thing and have to wait to get access to the CPU, right? I want that to conduct as fast as possible. Or if I have a high-performance system that has to do 100,000 things, and I sell lots and lots of things, that's something I want no one to ever have to wait for, right? And so there's a way to measure that waiting time for your VMs that are trying to get access to physical cores, right? It's a metric called CPU ready. And so that's a link on how to measure and interpret CPU ready for a platform. And generally, you don't want to be waiting. So let's tell a story. I've seen this a lot. Yes? Yes, please. Yeah. So I'm going to tell a story on how dramatic that waiting time is. And in 2 different scenarios. In a SQL Server scenario, I had a customer come to me once that had this. Right? So it's at 4 to 70. Is that 72? 72 cores? I'm really bad at math. And this is particularly bad because of how big these VMs are. So 24 cores, right? There's a thing called relaxed scheduling, but let's pull that off the table for today and just focus on high level. If I have 72 cores, they're all trying to access these 48 cores. At some point in time, one of these VMs is going to have to wait. And it's going to have to wait some amount of time, which is going to impact the ability for that VM to move forward in time. What I didn't highlight is how dramatic this is. When this system has to wait, it literally stops. Right? It's not on a CPU, it's not running, it's literally stopped until it gets back onto a CPU, and then its program state can move forward and finish its task. So for a SQL Server workload, things are kind of periodic. I'm not going to say it's going to be okay, but it can be masked a little bit. But you'll see job times slow down, things like that. I had a similar customer. Who's familiar with Citrix application servers? Anyone familiar with Citrix application servers? It's kind of like RDP, but with like all the rough edges that annoy you about RDP smoothed out in an enterprise fashion. And it's a way for users to access applications in an enterprise data center. But everything's remote. All that you get to the end user is the visualization of what's occurred inside a data center. So everything's happening over the network. And so I had a customer come to me once, and they were like, hey, our SQL Server, or our Citrix environment's really slow. The users click in the applications and nothing happens. I'm like, okay, tell me more. And they had a system that was configured similar to this. I was like, let's go look at VMware and look at the CPU ready times in your environment. And they're like, oh, no, we don't think it's that. And I persist. One of my good friends was in the room with me, Joey D'Antoni. We were both working at this customer, and I texted Joey while I was talking to the customer, like, Joey, how many times have I asked this customer for the CPU ready data? And he's like, 8. Like, listen, let's just log in. And I looked, and it was through the roof. I mean, it was like seconds. Like each VM was waiting multiple seconds to get access to a core. And so in both situations, the SQL Server situation earlier I told you about, and this particular application server scenario, I came back and I was like, listen, let's just do this. We'll go to 8, We'll go to 8 cores. Literally immediately fix the problem for both customers. 2 independent scenarios, but the end users no longer were seeing CPU ready, so they were happy. The database servers were no longer seeing CPU ready, and they were happy as well. So bigger is not always better when it comes to VMware sizes and configuring VMs. You have to figure out what's right for your application. Same customer that I had to ask 8 times to show me the CPU ready thing, almost always when there was a performance issue would jack up the vCPUs on their VM config, right? Which literally might just slow things down. In that specific scenario, it did. And it wound up being query tuning, but they would think in the old model of if I had a physical server and I had a gazillion cores on my physical server, it would just work better. And that's not the case in a VMware environment, right? Because you have to balance that configuration underneath. And so let's kind of look at that again. Oftentimes, especially in consulting, I would never get access to a greenfields environment. I would never go and like have a brand new environment to go deploy into, right? Who's ever had that luxury of like a completely brand new environment to deploy into, right? One person, two persons. And so chances are you have some data on your workload today that you can measure, right? Especially if you're moving into a new, if you're migrating from maybe an old server stack to a new server stack. So deploy and measure. Are you never experienced in CPU ready? Are you able to reduce the vCPU count on your system, right? There's literally software companies that do this with AI and ML to make recommendations to reduce the vCPU size of a VMware environment to right size it. Also applies to cloud too, because then that's like real money on credit cards, right? But we talked about this a couple times already. Tier 1 systems don't over allocate, right? Make sure that your vCPU count for the VMs that are executing on that environment don't exceed the number of cores in the system. But for the non-tier 1 environments, deploy and measure. You might be able to dial that back and have some savings. Yes? So a little bit of an advanced topic. How are we doing on time? Because I'm going to go on a huge tangent here. Okay, in a good way. So the question is, what's the influence of cores and sockets on the design of a system? Is that the next bullet? It's the next bullet. Did you see my slides? It's okay.
So that's a great question.
Yeah, fantastic question. Yeah, so I already made the statement about don't have too many vCPUs in there. Right size it is really what you want to shoot for. So cores per socket. When you buy a box, a physical server, it has a socket. A socket's where a chip goes into. You can have 1, 4, 8, things like that. By the way, anyone know Superdome's still a thing? And I learned like a month ago that Superdome's still a thing. But that's another conversation. So cores per socket is this. You buy a processor, you stick it in a socket, right? Or you have two processors, you stick it into two sockets. But does anyone remember, probably about 15 years ago, servers went from being like 16, 32 gigs of RAM to like, wow, I could put 768 gigs of RAM in a server now, or 2 terabytes of RAM, right? Anyone remember that kind of inflection point? And the reason why is because what they did is they subdivided the hardware across sockets, and they made these things called NUMA controllers, or memory controllers. And it's a responsibility on each socket to allocate memory from the memory associated with that physical, like that side of the motherboard, right? And so that has an influence on performance on this. And when I allocate memory, I want to have the locality taken into account of where that memory is allocated physically in the system, right? There's this concept of local memory access and foreign memory access. Local memory access on a NUMA node is really, really fast, right? If I do what's called a foreign memory access and go to another NUMA node across the street on the other side of that other memory controller, it's not really, really slow, but it's slower in the order of the number of instructions it has to execute to take that page and bring it over here and then do those things. When I say page, I mean like the physical memory page, not the SQL Server context of a page. And so when I do that, that can slow things down. So foreign memory access is bad, right, for high performance workloads. And so what you have inside of VMware in your virtual machine configuration is the ability to influence that, right? I can say I want this many sockets and this many cores, right? So you can do something like put 8 sockets in 1 core per socket, which is going to give you 8 vCPUs. But this is what you actually have to worry about, is licensing. Licensing, right? Is that SQL Server Standard can only address the first 4 sockets. Erin Stellato, who's presenting today too, she has a cool video about this where she shows this in action, where what a customer, when she was at SQL Skills, had many, many sockets, but they were only seeing a workload being distributed across 4 CPUs in the VM, because it could only address the first 4. You only get schedulers for that. And so the VM will tell you, hey, I got 32 cores or whatever the config is, but SQL Server, because of licensing, will only say that. And this will show up in your error log too if you're out of configuration. So when you do configure that, just take that into account, or run enterprise and just make Microsoft happier. Right? Before VMware ESX 6.1, that mattered. You actually had to make this configuration such that it influenced the NUMA topology, all the fancy memory stuff that we just talked about a minute ago. After VMware 6.5, it just automatically calculated it for you the right way. So you don't have to worry about it anymore. All you have to really worry about is this part, this licensing part. Cool. So the other one, free latency. Who likes latency? Anybody like latency? Right? Like something like when you get up out of bed. Like, I don't want to get out of bed yet. That's good latency, right? So there's a concept or configuration parameter called CPU hot plug. Sounds cool. I can hot add CPUs to my VM, right? Super awesome. Great, no downtime, but it's free latency. So back in the day, I think that's the next slide, in the older versions of VMware, 6.7 and change, 20-30%. That sounds cool, right? Not too cool, not too cool. Newer versions of ESX have been eating away at that. So the performance penalty hit that goes associated with that, I believe now is in single digits. But still, it's free latency. So you check that checkbox because it sounds cool, things are going to be slower. So uncheck that checkbox, right? Cool. Any questions about CPU, team? Pretty cool.
I would assume if something like a SQL Server workload, you'd want to rather have one socket with lots of cores and dedicate those cores plus the memory that goes with that socket to SQL rather than across multiple sockets where you're going to have to keep going across with foreign memory access.
Right, so SQL Server, so that the question is, I think the paraphrase, when SQL Server allocates memory, like how does it know where? Is that what you're kind of asking?
Well, say from a performance point of view, would you rather have one socket with lots of cores
Oh, okay.
so that you keep all of the memory based on one socket rather than have multiple sockets and
Understood.
do foreign memory access?
So the question is it better to have just a socket or more and prevent foreign memory access? You shouldn't care. Both VMware and SQL Server understand the locality of the memory, and under certain memory pressure conditions will exchange the data for you under the hood. It'll move the memory pages from one side to the other, but that costs time, right? And it's surfaced as a performance metric inside of SQL Server in Perfmon, and the DMVs too. The idea is SQL Server is NUMAware, so it's going to go and access the memory local as fast as it can, but due to if there's memory pressure, if you have a multi-socket configuration and you are using 2 NUMA nodes, it'll balance that out in pressure scenarios, and so will ESX. It'll do something similar such that you can. So the idea is you shouldn't have to worry about it, but you might see performance problems under certain conditions where it might have to evacuate one side to shift to another, but that'll be surfaced in Perfmon and DMVs. So did that answer your question?
Yes.
Okay, yeah. I guess it's hard to say like don't worry about it until you have to, but don't worry about it until you have to.
Just don't use one socket, one call.
Yeah. Okay, so let's talk about memory. So each physical server, again, we're focused on one server and how it allocates memory and how it's going to be consumed by the virtual machines. So let's say for easy math, I have a physical server that brings 0.5 terabyte to the party, and I allocate some VMs in a configuration that looks like this. I'm going to use easy math here. This adds up to 512 gigabytes. There's 512 gigabytes in the server. There is some overhead for the server in the order of gigabytes that it would have to do just to run and execute the environment. But for easy math, let's just assume it has 512 for today. Okay. So what happens when I do this? Is that bad? Right. So lots of things can happen when this goes down. And a lot of it has to do with what nerd knobs you turned in the configuration prior to this, okay? And so let's talk about some of those nerd knobs. What's going to happen when you do this is if all these VMs, let's say the buffer pools are pretty full, 80-90% on each VM, 60 gigs here, maybe 220 gigs down there. What's going to happen when this happens is I need real memory. This isn't a resource that I can multiplex, right? I can't, like a CPU, I can't kind of push things off and on like you can with memory. I have to actually allocate memory to these systems to be consumed. Now, there's cool stuff happening like page deduplication and whatever inside of here, but that's not enough to influence, I don't think, the calculations when you're architecting a system. And so what memory ballooning will do in a scenario, so if I bring 512 gigs and I bring the 64 additional gigs to the party, I need that memory. Like that VM needs to get that from somewhere. And where's it going to get it from? It's got to get it from this physical server down here. And so what memory ballooning will do is it'll find a VM, a candidate VM, that has a lot of memory associated with it, and it'll start a process inside of that guest, and it'll grow. That process will grow and allocate just a buffer, and then it'll delete it. What's that gonna do? That's gonna cause SQL Server to realize that there was what's called external memory pressure, and it's gonna dump its caches, right? So things like the buffer pool, which are kind of cool, right? Your plan cache, also cool, right? And those things are gonna get evacuated because I need to get that memory added to what's called the free list down here so that this VM can have access to it. And so now I have that VM with a maybe empty buffer pool, and I have a plan cache that's suboptimal for my workload. So what's gonna happen? The performance of that VM is gonna go down, right? It's gonna slow down. It's gonna have to build new plans. It's gonna be conducting more I/O. Everyone's sad. So don't over-allocate memory is the story here. But what if I have locked pages in memory configured? Who has that configured by default as a best practice for their VMs? All right, about half of y'all have this configured. I love locked pages in memory because generally when I build SQL servers, they're dedicated to that SQL server. And similarly, I won't over-allocate memory on a physical or in a VMware environment. What locked pages in memory will do is the address space that's associated with the SQL server process that's running on the inside of a VM is it won't respond to external memory pressure. It's gonna say, you know what, I'm cool. You just don't get memory because I'm gonna have those locked, right? So what's gonna happen when the balloon driver starts up and it can't get enough memory for that individual VM, right? Bad things can really start happening, which we'll talk about in a second. What about memory reservations? In the actual VM configuration itself, I can say this VM always has 64 gigs of RAM. So now I'm asserting configuration. I'm saying never page, and I'm saying you always have 64 gigs. And so if I have a VM that comes along and needs additional memory above physical, and I can't balloon, what's gonna happen? It's gonna swap, which means you're gonna have memory transactions that you expected to occur in nanoseconds that are now gonna occur at storage speeds in milliseconds or microseconds, just saying. Sorry, I couldn't resist. Swapping to disk. In a high-performance system, you never want to be in this situation, right? Because everything's going to drag down. Not the 64 gigs, the new one that came along. The whole platform will slow down because the entire physical system is under memory pressure now, right? This is a big, big, big deal. This is where you don't want to be. This is, just as a quick sidebar, if anyone's worked with Kubernetes, this is the primary reason why Kubernetes actually has you disable the swap, because it thinks it's better to overall just kill a VM, or in the context of Kubernetes, a container, and protect the overall stability of the system than it would be to drag all of these VMs, or in the Kubernetes world, all the containers down and slow things down, which I think is a pretty good design choice, because in the Kubernetes space, I can just start up a container somewhere else in the cluster. Similarly, we could do that here. So don't over-allocate. That's really like rule number one. You might want to consider setting memory reservations to prevent ballooning for your tier 1 workloads, right? I'm also of the configuration philosophy, is that how you say that? Of not turning as many nerd knobs as you can, but this is one of those ones for tier 1 workloads that I'd encourage folks to do. And you want to monitor and alert on ballooning. If you're ever ballooning, you need to know. And you need to call the VMware admins. Who were the 3 VMware admins, right? Yeah. Call them up and be, listen, we have a situation. Because memory is cheap-ish nowadays. When I was a kid, it was like $50 a meg, which was a lot. But you want to know if this is happening. This is something you can configure inside of VMware. So, cool. We're doing about 10 more minutes? Ooh, okay. Okay, so the first question is, what is the best way to identify how much memory and CPU is required for an optimized SQL Server database? Ooh. I know what to submit for a pre-con next year. So I guess out-of-box applications, your application vendor is going to give you some sort of suggestion based on what they know, right, about their systems. But let's say you wrote an application. I've done this in my career, and I've written applications that had the function at scale. Is you test, right? You figure out what's important to that application. What are the key metrics that you need to optimize and help achieve those, right? Generally, I worked more in the OLTP side of the house than the data warehouse side. And so my brain is always tuned on shopping carts, working in context of medical situations where things had to happen quickly. And so the metrics that I would be concerned about in those scenarios is, having enough memory for the buffer pool, can like flush the transaction logs out as fast as I can. And then CPU, the amount of CPU, especially in a VMware context, it's such a hard thing to think about because there's more in play than just saying how much does this SQL Server need. I need to think about the whole platform and how that's being consumed. I know that's like totally a non-answer, but I'm sorry. I think everyone knows where I'm coming from that one. From a licensing perspective, it was financially interesting to perform overallocation on CPUs in virtualized environment. Even Microsoft used this as a sales argument in their consolidation database appliance released in 2011. Am I understanding you correctly that overallocating CPUs in virtual environments where SQL Server is running must be, and it's totally cut off? No, it's not. It should not be avoided. Should. For tier 1 systems, I would only do it for performance reasons. I don't ever want to wait. Right? For non-prod systems, that's where you're going to gain the economies of scale on your platforms. When you're licensing SQL Server in VMware environments, this is actually one of the better licensing guides. The SQL Server 2019 licensing guide goes through how to license VMware or for virtualized systems, and it covers it in pretty good detail. In most of the enterprise customers that I worked with, we always had what's called an enterprise license, where you can just run as many VMs as you want and not have to worry about. I don't think I've ever come across a scenario where I've had a VMware license or a VM license for SQL Server I had to license by core. So I don't have a lot of experience specifically with that question, so sorry. Okay. How are we doing on time? 10? 20? 10? Okay. Ooh, that's 13, that's troubling. All right, so disks. What's that? Yes?
How reliable is Perfmon in your VM reporting the CPU usage?
Ooh, that's a good question. So how reliable is Perfmon in reporting CPU usage? I think in the early days of virtualization, it was problematic. I think it's since become a more reliable metric for CPU. But when I look at the performance utilization of a system, I don't look at CPU, actually. I look at how fast am I conducting the things I needed to conduct, right? Now, I want to go as far as I can on this, but I want to stop at this point. For VMs, 60% is the max I would ever want a VM to work at, because I want to have some headroom for things to go wrong, right? Like a query plan to go wild and still be okay. But no, I think nowadays it is considered a reliable metric. And so let's get into some I/O. So inside your VM, when you create a virtual machine, you get this thing called an LSI storage adapter, right? This is the default. I guarantee almost all of you probably have that configured in some VM in your environment. And the other choice that you have, which is the non-default, hopefully soon to be default, is what's called a PV SCSI adapter, or a para-virtualized SCSI adapter. And a para-virtualized SCSI adapter is going to be a more optimal way for you to conduct I/O from inside the VM to outside the VM to where your data actually is. We're going to add multiple PV SCSI adapters to the VM, because each one of these SCSI adapters provides what's called a ring buffer, or a way for I/O to leave the VM. More is better, because then I can conduct I/O in a parallel fashion, but I can have only up to 4, unfortunately. I wish I could have more. And then you're going to lay out your disks in some way that look like this, but this is just an example, not like a best practice. But you're going to break up your workload across those PV SCSI adapters in some way. That VM runs on a physical server. That physical server is going to be connected to your storage network via some interconnect, fiber channel, iSCSI, and that's going to have some sort of performance profile associated with it. That's probably going to connect to some sort of storage device in your data center, which also is going to have an interconnect that will have some sort of performance profile with it. And so when I do testing, especially in this scenario, this is where it gets really nerdy, is I generally will get the manuals associated with the HBAs or the NICs here to find out the performance profile of them. And similarly, I'll do that for the storage network and for the network interconnect. Why? Because if I'm building an infrastructure and I bought 32 gigabit fiber channel here and 64 gigabit fiber channel here, and I'm getting 1 gigabit of fiber channel or 1 gigabit of throughput in my VM, who's going to be happy? Not the person that wrote the check for all that fancy stuff in your data center, right? And so I always took it upon myself to make sure that I literally was getting what I was paying for. And I would do load tests. I would walk down this stack, and I would make sure that I was getting 32 here, and I was getting 64 here, and I wasn't saturating or getting any queuing along the way. right? Because your data lives here. And you're gonna have many physical servers across your cluster, and you wanna make sure that you can get access to that data as fast as you can, because when you conduct I/O, it's gotta traverse this entire path every time, right? And this hopefully functions as optimally as possible in terms of throughput and latency. And so as awesome as virtualization is, you have now all of these layers to look at from a performance standpoint, right? Inside a SQL Server, I have DMVs to help expose performance data to me to understand how fast I'm conducting I/O, how much and how quick, right, in terms of latency. Perfmon will expose those metrics as well. A vSphere also has metrics here to expose to you and your VMware admins. Chances are your networking team hopefully will have some sort of monitoring here that will tell you what's going on inside the storage network. And companies like the company I work for, we have vendor-specific tools that will show you the perf data here. Sounds fantastic, doesn't it? Right, not so much. But if you're building a high-performance system, you need this kind of visibility to understand like where the latency is in the platform. And I've been playing a lot with the Grafana stack lately and Telegraph and things like that to build dashboards that help me understand the platform more so than having the point solution tools. And so that I can correlate data from DMVs, from Perfmon, from vSphere, and from the network, and all the way down into the vendor tools. Most folks will expose data in some way that you can build a dashboard to see these things. I've been spending a bunch of time working with that lately. Because now if I have a single pane of glass, I can quickly identify where the bottlenecks are, right? If I see no latency from the physical server into the storage interconnect, but I see a ton of latency from the storage interconnect into the storage device, where am I gonna look first? I'm gonna look there, right? And so seeing that in an environment is super critical. Like for me, to visibly be able to see it in a dashboard is super critical. So I'd encourage you to look at those kind of tools to get that holistic view of the situation.
Excuse me, if this example is, you think is fully applicable in Hyper-V platform?
In Hyper-V? Is the question? So does this apply for Hyper-V? No. Hyper-V, you actually want one storage controller. And the reason why is because Hyper-V, VMware, the ring buffer that I talked about earlier is fixed size for each PV SCSI adapter. So the only way you're gonna get a bigger buffer is to have more, right? And that's how we're able to do that here. What happens in the Hyper-V side of the house is that ring buffer associated with the storage device or the pair of virtualized storage devices dynamically grown based on the number of disks that you attach to it, right? So that's the key difference between the two, okay? Cool. We got about 5 more minutes. Let me answer that offline because we're kind of coming up on time here. Cool. Got about 9 more minutes. Yeah, cool. So all the stuff that I talked about with VMware config and things like that, what I want you to do, and I always did this in every consulting engagement I was involved in, is I would take the configuration and I'd bake it into a template, right? If I'm gonna go and configure Windows for best practices and configure the VM for best practices with like hot add and all the PV SCSI adapters and all the virtual disk configuration, I wanna take the thought out of that configuration. I wanna think about it once and leave it behind. And then when I come along later, what I'll do is when I create the VM at provisioning time, I'm gonna scale the system in terms of number of CPUs, number of memory, and how big the disks are. And I'm gonna do that at the time when I need the VM. But all the operating system stuff that we talked, or we didn't really get into the OS stuff too much today, but and all the VM stuff that we talked about, just bake that in so you never have to think about it again, right? Or when you have to do operating system upgrades and things like that, just to reevaluate those configuration decisions if they're appropriate in your environment. Because what I don't wanna do is have a lot of configuration skew or have one VM that has a performance issue because I forgot to untick a box, right? And so make sure you just set that and forget it, okay? The other thing, and it's not really so much about building VM configurations, but the number one thing I would do is not click buttons, right? I was huge into automation, PowerShell. In fact, I was talking with Andrew Prusky this morning about some customer stuff that we're working on, and I went back and through all the pester tests that I would have to make sure that the configuration of the VMs that I had matched what I thought they were. And so I'd write automation to make sure that the NUMA topology was right, that I have the right number of storage controllers attached to the VM, and I could run those checks in my environment over and over again in an automated way, right? And so you can go and you can configure all the nerd knobs in your environment, specifically inside a SQL Server, to do the things that you might do, right? And so in this case, those pester tasks checked for all of these things, right? Is the data file layout the way that I want it? Is tempdb configured how I wanted it? Is query store turned on? Are the community tools that I would use in production environments available? All the Hallingren scripts, Brent's stuff, and things like that. Are there jobs scheduled for indexes and maintenance? And are there backups configured? So this really doesn't have much to do with high-performance SQL Server on VMware, but building a supportable enterprise platform in a way that I could have a stable system that's checked in an automated way with Pester to make sure that all of these things were configured, right? Cool. All right, coming in on time almost. So yeah, we talked a little bit about hardware, but really we talked much more about how we're going to consume it, right? More so than the actual configuration of the physical servers themselves. When you do get into the physical server configuration, talk to your vendors, talk to your hardware teams, and have that conversation. That's really what I wanted today to be about. It's like, what's good look like, or what bad looks like in some scenarios. And talked a little bit about VM config, how I configure SQL Server, and we talked about some storage along the way. So I have some resources in the deck, DBA tools in the house, pretty much my go-to for configuring and managing SQL Server, installing, configuring, all the stuff that I talked about. The pester tasks that I would use, right? All based off of that stuff. I think it's like in every presentation I do now. Anywho, Ola's stuff, Ola's in the house, just go shake his hand and say thank you. Let's be serious. I think I'm working on a project internally, and it's some non-SQL Server pros are doing some work with SQL Server, and they're like, hey, we found this thing on the internet, and it configures backups for you automatically in index maintenance, and they're like, what is it? Like, Ola's, and they send us a link, we're like, yeah, you're good, all right? And so, added mechanic stuff is fantastic. So these are all the tools that I would use in my consulting practice to maintain and configure platforms. A lot of the stuff that I talked about today is available on this blog post here, and it's based off of this 75-page VMware document here. They just refreshed this, actually, a few weeks ago. Fantastic read, super deep dive stuff. I kind of waved my hands about some configurations about how they should be asserted. That will tell you why, right? And we could spend all day talking about that on the why and the internals of that. So I appreciate y'all spending time with me. Hopefully I will have a Guinness tonight and not a Heineken. And I hope, I'm just kidding. Andrew did a fantastic job, but I appreciate y'all spending time with me today, so thank you.